able to act, we are able to respond to situations than react to the situations. So that's how digital twins are actually going to be very helpful. Just as a fact check, I just wanted to bring some importance about why it is the right time for digital twins in infrastructure, because it's projected to by 2030 that the global infrastructure investments are going to be about 94 trillion, and which is huge investments that are actually going to be coming up. Second, I think 65% of the infrastructure assets are working in a suboptimal levels. So there is a huge amount of opportunity for us to improve the performance. And last but not the least, the failure of infrastructure or a poor quality or poor maintenance of infrastructure is resulting in a loss of about 1.5% of the total GDP annually. So this actually brings in a lot of importance and emphasis on how we can improve what is actually happening and how technology can enable us to do this part. And digital twins are a good answer or a good solution for us to look at to see how we can actually achieve these things. And from here, the other important thing that is actually also emerging is we are all seeing that as the trends in transportation mobility that are actually moving, we have almost close to about 70% of or 68 to 70% of urbanization is what we are envisaging that is going to happen in the country today. And then we are also seeing that almost close to about $300 billion of damages is actually being caused due to climate related events, that including the floods, the flash floods in the cities or other infrastructure. And moreover, we are all government is also constrained with the availability of the funding for infrastructure. So that's also one important thing that we need to look at it. But on the contrary, what the best part is the technology, especially the global twin technology, is picking up momentum. It has proved its success in various parts of the globe, and also there's a lot of potential that we actually have for its utilization in the urban infrastructure as well. So we are actually moving towards how this technology can be leveraged, and I don't see any reason why we in India cannot do this part. So and that's where my focus is actually going to be in trying to bring in use cases for those kind of things. Now, before we step into what these digital twins are, just to create some sort of an excitement about how these digital twins have helped the agencies across the globe, I just wanted to throw out some numbers again here. And the use cases where it is actually getting deployed and has seen some success of the day. One is about the predictive maintenance and reducing the downtime of the infrastructure. So we actually have seen this successfully deployed in London Heathrow Airport, where we have seen that downtimes have been brought down by 25%. We have seen this being actively deployed in Singapore by Singapore Land Transport Authority, which reduced the cost to an extent of about 30% in their rail maintenance activities. Second important thing is about how the asset life cycle can be optimized. So the Netherlands, we are a Dutch company, and then we see that we have been able to use digital twins there to actually enhance the asset life by almost by 15 years by avoiding those replacement costs. The third important use case where it has been proved successful is in the climate and the resilience side of the story, where digital twins have helped Queensland, Australia to reduce the damage exposure by 22%. And similarly, Oslo authority has reduced incident response times by almost by 60%, right? And we also see that the citizen-centric service delivery has also seen a lot of improvement in terms of the satisfaction of the users going up by 40%. Because of digital twin, the response times to the issues escalated by the citizens have also found better and faster responses. Coming with this, the background, the point I'm trying to make is that yes, the this technology has been around the corner for quite some time, has been deployed across the globe, and has really found some success stories. And that's where I think we move to the next as to understanding what this digital twin is all about. What is it made of? So, most importantly, the digital twin is all about the virtual replica of the infrastructure, physical infrastructure that we see in the real world scenario. So, this actually comprises, for it to be active, we need about 4 different layers of information here. One, we definitely need the physical infrastructure, which is equipped with the sensors, which would actually grab the data that would actually make it to be monitored in real time. So that is actually facilitated through a lot of these IoT sensors, lidar scanners, and SCADA systems that are actually deployed across, to which become the point of source of a lot of data that it generates. Second, once the data is actually been generated, we need to be collaging this or fusioning this data with the other third-party sources of data, like the climate or the environment that it is operating, the people who are actually using this infrastructure, and the kind of uses that the infrastructure is actually being put to. So all that data is also important for us to the sensor data with the third-party structured and unstructured data that is actually going to be brought in, to be integrated in a very structured way for us to actually be put to different algorithms for it to actually come out with outcomes. The third important layer is the intelligence layer, which actually talks about setting up of algorithms, predictive models, simulations, and anomaly detections that it needs to do. So a lot of these algorithms are stacked in this layer, which uses the data from time to time and in real time, and try to predict the how the infrastructure is actually going to be responding to the different conditions that it is being exposed to from time to time, or different users it is actually being put to from time to time. So that's important for us to this is the brain of the whole digital twin is this part. Then comes the action layer. So knowing about things is not important. It is all about the situation. This only creates a situational awareness. But once we know, it also need to actually throw up the actionable intelligence as to understand, okay, now I know what it is going to be. What do I need to do as a stakeholder? There are different stakeholders that are actually going to be engaged in the whole scheme of things. How do we, as multiple stakeholders in the ecosystem, respond to this by performing the respective roles that we play in the whole ecosystem? So that brings us to the most important and the topmost layer, is an action layer, where we actually have dashboards, we have alert systems, we actually have MIS reports and the central monitoring systems, and the process automations that are actually going to be set up in the whole scheme of things. So this broadly is the technological aspect of what comprises of a digital twin in the whole scheme of things. Now, what makes these digital twins successful? It's I always keep saying in almost everywhere, in every forum that I speak, the technology is only an enabler and not an end in itself. So what is important for us to look at it is, what is making this technology work is the brains or the people behind this technology is very important for us to consider. So for people to act, what do the people bring in the whole scheme of things? So the stakeholders bring in their domain expertise, which is the most important aspect when in making the digital twin successful. So the core engine is not the technology, but the domain expertise that people bring to the table is the most important thing that we all need to understand. So to demonstrate this, I just summarize the whole importance of these domain expertise into four different categories, and then how this has been helping in real world is also I try to summarize in this table, where civil and structural domain expertise is very important for us to ensure we calibrate, validate, and put the stress and fatigue models to use. And this has been demonstrated very well by Hong Kong through its twin bridge monitoring. In transportation engineering, there is a multimodal movement and congestion management that actually comes into play, where again we need a lot of domain expertise coming in from traffic engineering. And that is also been demonstrated through the London Transport for London using its twin for bus and tube integrations. The third important domain expertise that generally is put to use is our environmental and climate related stuff, where we are able to assess the climate risks and runoff and flood modeling and those kind of things. And where again, NYC, New York City has put to its assessment the sewer overflow planning that has been done for. The last and most important thing is also about the operations and asset management side of the story, wherein there's a lot of efficiency that can actually come in making sure that there is a different stakeholders are made to come to play, and then how the city of Boston has put its park asset twin to use. So I'm sharing these examples, and this presentation is also will be made access so that you all can go through this in detail, and can also be thoroughly examined about how this every stakeholder has actually put it to use. And the other important aspect is that every digital twin is will become efficient along every aspect or every stage of the life cycle of the project, of the infrastructure project. So this slide I was trying to summarize how an digital twin can actually help in terms of uh, planning and design, in terms of construction, in operations, in maintenance, and renewal and upgrade of the things. Like for example, in planning and design, we can actually have this data help in simulating multiple infrastructure scenarios and identifying and prioritizing which infrastructure is the most important, where the investment needs to go. So when the funds are constrained, we need to prioritize these investments, and that can be the best when you have the real-time data available to you, and it can overcome the limitation of today's process of DPRs being prepared, and the construction of the project actually starts 5 years down the line, and then another 5 years it takes to build the infrastructure. By the time the 10 years, the DPR goes defunct, and the data that on which it was actually been done itself has actually gone to toss, has completely changed and completely transformed. So these are the situations where the digital twins come to rescue and helps us to plan for to date. And while we are designing, while we are constructing, we also need to know how things are changing, and any responses or any changes that need to be done in the process can also be taken and put to use. And this also helps us, digital twin also helps us to test the infrastructure even before it is being built, to for exposing it to different climate risks, or different usage risks, or the different types of loadings that are actually possible. Multiple veracity and variety of things that can actually come in can also be tested and tried here, and ensure that how we can also bring in the multi stakeholders. Every stakeholder can look at it and experiment on this digital twin from their own respective aspects. Now, similarly, in construction, we can actually monitor the how the progress of construction is actually happening, and how to sequence things to make sure that the construction happens faster, and how the supply chain management can be done, and so that the process doesn't stop, and how the market response, like say there is a shortage of one material that is actually being anticipated, so we know how to actually replace that with an alternate material can also be done, and then quickly we can actually change the designs or change the way the construction sequencing can be actually changed, and methods can be modified. A lot of these things can be done while with use of twins in construction. Same way, I think in operations, it's no brainer that when in operations is where the digital twin plays the most important role and helps in improving the situation the most, and to ensure that the day to day, how the usage of the asset is actually being put to use, how the maintenance of the asset can be taken care, is the next stage, where the deterioration of the structure, or different elements of the infrastructure can also be monitored, tested, and interventions can be put to place. Similarly, renewal and upgrade, again, this is where we can actually simulate and prioritize and justify the capital investments that can actually happen. And now coming to the third important enabler of the whole scheme of things is a digital twin is only and as successful as it can be only when you are actually able to enable the multi-agency collaboration to actually happen. So without which the digital twins are not set for only one stakeholder. We need to actually ensure the multiple stakeholders' perspectives are actually brought to table, and the twins are actually being built, the scenarios are being modeled with the multi-stakeholder engagement, keeping in view of that part. Like one of the classic cases that we could see in India itself, the Gati Shakti platform that is being built, and it's an early stage of a digital twin. So where we can actually see that there are about 17 ministries who are brought to one table, and how multi-agencies are actually able to collaborate to make sure the construction or planning and construction of infrastructure projects are actually happening at a much faster pace than what it used to be earlier. Like, for example, Barcelona Urban Twin, there are about 10 agencies who have come to table. Like UK's National Digital Twin Program has brought all the three key utility providers, service providers, to one common table for work. And the benefits have been like the projects have been delivered in about 40% faster. There has been an improvement in about 3x times the improvement in the infrastructure use. There has been a reduction uh, of duplication to the extent of by 50%, we could actually see. And these are all the data that is being published, and it is actually available for us to validate as well. So that really establishes the fact that only when the digital twin is deployed for its utility through the life cycle of the project, only when there is multi-agencies collaboration is being enabled, and only when the domain expertise actually is put to use in digital twin, that it's able to give the maximum benefit to its users. So with this being in the background, I would like to quickly run through a few use cases. Uh, IRF being more vocal about road safety, I tried to include about three use cases which are about road safety. And of course, asset life cycle, and also in terms of operations, I tried to put about five use cases where this has been, digital twin has been put to use. Like, for example, how a digital twin can help in road safety is in terms of hazard detection and proactive interventions. Like, even we have been able to, we should be able to do that in our highway ATMS as well in India. So in Amsterdam, Netherlands, they have set up a digital twin smart traffic system on their roads to actually test. As you all know, Amsterdam is supposed to be the cycling capital of the world, and you have maximum number of people who are actually driving cycles in the city, but they always come in conflict with the other vehicles, and to actually ensure that how the safety can be, safety of those vulnerable users segments can be better managed. And that's where the real-time data plugged with the roadside information, we are actually able to identify the conflict or near misses that are actually going to happen. And then we have been able to set up some sort of a restrictive, proactive measures been adopted to make sure that those conflicts can be reduced, and the safety of the cyclists and the pedestrians is actually protected. And this project over a 3-year period has brought down the fatalities from or accidents from by 27% almost. So this has also helped in redesigning the infrastructure to ensure that the safety is actually enabled. So this is one case study where the demonstrable outcomes have been shown. The other important use case is actually about use of digital twins while the infrastructure construction is happening in the work zone safety, and assessing the construction risks by simulating the construction activities in the on the field in the work zones. We have been able to identify the potential risks or accidents or disasters, and we have been able to see how that can be brought down, especially in the this case study has been picked up from USA Colorado DOT has deployed this part, and they've been able to reduce the work zone incidents almost by 40%. So this is a substantial impact that we have been able to showcase in this case. The third important is like when there is an incident, and then the response has to be fast, and then response has to be more appropriate. So we have been able to set up this digital twin in Queensland Transport Australia, and this twin has been able to integrate the data from the cameras and ANPR, and a lot of these vehicle kinetic data has been brought to, where we have been able to detect the incidents instantly, and we have been able to trigger an automated response plans and alert to the control rooms and all the first responders and the ambulance and other people, and we have been able to bring down the response time by almost 22%. So this is again a major change. And just to give you an example where we have been able to do a similar, not a full-fledged digital twin, but we have been able to set up. We are in the process of setting up a mobility digital twin in as an example in Bangalore as well. We are doing, and in one of its first, some of the use cases that we are actually trying and experimenting, we have been able to reduce the response time to ambulance response times or incident response time by the ambulances almost to the extent of 30 to 40% reductions were possible when we are able to sync up these things. The fourth important use case that I was trying to bring in, where digital twins have been very useful in traffic operations, is about this use case comes from Finland, Helsinki, where the city digital twin has been deployed for monitoring the traffic flows in real time, and making sure the signal timing plans are actually optimized, the contra flow lanes are actually being deployed, the proper diversions have been actually been implemented from time to time, making sure these interventions are being made, because the digital twin helps you predict the situations based on the way the trends are emerging or the data is coming in real time. And they have been able to almost like the commute time reductions have been to the extent of 15 to 20%. And there have been instances of the transit schedule adherence has been improved substantially by about 30% in this case. So this is how it's been helping. And last use case is actually about the asset lifecycle cost optimization. The use case again comes from Netherlands, and this is where the highway agency has been actually been monitoring about 1,000+ by using the digital twin platform, and they have been able to develop these deterioration models, and with the live sensor data being captured, they have been able to model for different loading conditions and different climatic conditions, and they have been able to make sure that right interventions have been brought to table, and they have been able to save to the extent of 100 million euros over a period of 5 years. And this is one of the best examples that can be most suited for the Indian environment as well, because there are so many bridges across national highways which are actually in a very bad condition, which can actually be deployed. So that is something that we can actually look at deploying. Now, having said this, one of the important things that I would like to summarize the whole presentation is by putting the summary of the whole scheme of things is about how one should start about setting up these digital twins. What are the key steps involved in coming up with setting up of these digital twins? The one of the most important aspects that we need to look at is we need to make sure that we are institutionalizing this digital twins, and the governance ecosystem is actually deployed. First, the awareness about the digital twin has been created, should be created. People should be aware about how the digital twins will be useful and helpful, and how they can actually put this to use. And once they are convinced and they are all agreeing for setting up of a digital twin, we need to know who does what in the whole scheme of things. And the setting up of the entire thing has to be who will design it, who will bring the data to the table, and the data sharing arrangements have to be put to right to use. The second important thing is about making sure that all infrastructure across the city are enabled for digital twin. That means they are all set up for these IoT sensors that are actually been put so that the data is actually being collected on a real time, because the only thing that differentiates between an offline simulation model to a digital twin is the real time framework. So the data should be coming in real time so that the digital twin is more effective. The third important thing is, before you step into a large scale deployment, make sure that we create those living labs where the engagement of all the stakeholders is actually happening. The pilots are being done, the tweaking and amendment of the whole architecture, or the way the digital twin is going to be put to use, is being structured better through these pilot. Lessons are to be learned, what works, what doesn't work. So those things have to be done. So living labs are important for us to make sure that we regulate this entire thing. Fourth important step is make sure that the investments in the domain are actually being done, especially the engagement of the domain experts, and making sure the right kind of models are being developed for each of these domains. Like, for example, if it's an electrical one, the SCADA model has to be developed. If it's for sewage or stormwater drainage, the flood models are actually set up with those experts. All the with transport, a mobility twin to be put to use, a mobility expert is engaged. So all these things are actually important to make sure the domain experts of right capability are engaged. And last but not the least, make sure that we are also making sure that all these digital twins are actually being addressed to delivering an outcome in place. Like, whether if it's a mobility twin, make sure the mobility outcomes are identified, and the twins are designed to ensure that those outcomes are impacted, and they are monitored for their outcomes. So that's the five principle, or that is actually important for us to understand, to make sure that the digital twins are put to right use, and then the benefit is actually taken. So with this, I would like to thank for giving me this opportunity to present. And with last one statement that I would like to leave you all with is like, a digital twin is like the way we actually heart monitor is actually being put to use, or it is something like a GPS that actually gives you the live location. So it is important that we need to understand that we need to put it to the right use. And this is how it can actually, the way the GPS helps us to move in the right direction, and also tells us the way if you are going wrong, or to choosing a wrong path, and it realigns us to the right path so that we reach our destination. So it's important that we need to treat digital twins like GPS devices. So with that, thank you very much, and I'm happy to take any questions if you have. Right. Thank you.
Thank you, Mr. Venkat. In fact, you have explained the whole concept very lucidly, especially when you talk about the anatomy of digital twin. So it's possible many of our attendees, they can relate to various modules. Somebody can say, yes, I have used GIS. Somebody can say, yes, means I used AI. So the various components people are familiar, but how to develop a case study, that also you have explained. And like in India, we had the smart city program. So I believe like there are various components which are tried in the smart city. It's possible that to create a digital twin, you can utilize some of the resources which was created in that. But I'm sure, like I also mentioned this to Professor Sigdar, that we need a much more elaborate and detailed discussion on this particular topic. So that will generate better confidence. That will also help to develop Indian case studies. And I'll request attendees to put questions maybe on the chat box, or they can share with you separately, because we are all delayed and you have to also leave. Only
Yes, sir. Yes, sir.
I'll request Professor Sigdar if he has to say, or if he has some questions.
I mean, questions will be taken at the end, but I simply have a comment at this stage. I know very little about digital twin. Right at the moment, because of this last few days development, I'm feeling like having a DT, digital twin of line of control. A living line of control is required.
Yeah.
I mean, using LiDAR camera, IoT, SCADA, etc. We must be able to monitor and see what's happening there. And anything we want to do, we should be able to do that. And
Yes.
what comes to my mind that we can have a DT for LOC. Thank you.
Yes, yes,
Thank
yes.
you.
Right, sir.
That's my comment at the moment.
Right.
So thank you, Professor Sikdar, and thank you, Mr. Subbarao, for
Yes,
that
sir.
full presentation.
Thank you, sir.
And,
Thank you so much.
if we have any questions, we will share with you for
Yeah.
your feedback
Right,
and
sir. Right, sir.
response. That we'll also share it back with the attendees.
Right, sir. Thank you
So,
so much, sir. And thank you. Right.
yeah. So with that, we'll now move on to the second presentation. So I hope Mr. Bharani is present.
Yeah, he is present.
Yeah. So I would introduce our second speaker, Mr. Bharani Kumar Depuru, who is CEO of AI SPROI and 360 DGTMG. He is a chairperson of AI for ITS Forum India and visiting faculty at ISP, formerly with HSBC, Infosys, Deloitte. He is with 20 years of experience in technology and business leadership. Mr. Derupi is a distinguished figure in the AI and data science ecosystem. In fact, in our flyer, we talked about two things. One part is the digital twin, the other part is on artificial intelligence. And as the founder CEO of AISPROV, an AI service firm, and 360 DG TMG, a global edtech company, he leads strategic initiatives that blend innovation with the real world impact. Under his leadership, these ventures have empowered thousands of professionals and enterprises across domains like healthcare, manufacturing, and road transport. So he's also the chairperson for AI implementation at the ITS Forum India, actively contributing to national level AI framework for intelligent transportation system. He is a visiting faculty at ISB since 2019 and currently engaged with London Business School. He shares his expertise in practical AI applications, bridging academia and industry. And as I have said that he has worked with the top tier organizations like HSBC, ITC Infotech, Infosys, and Deloitte, driving large scale digital transformation projects. And I'm sure his inputs with respect to AI application in road infrastructure will be extremely useful to all of us, those who are attending this webinar. So with that, I invite Mr. Bharani to deliver the webinar.
You are muted. You are muted. Please.
Yeah. So this happens almost always. So sorry about that. And thank you so much, Dr. Parida, and thank you so much, Professor Sikdar, for that kind introduction. And thank you for IRF India chapter for organizing this webinar. I would like to share my screen and get started with the quick intro. I understand that we lost some time, so I'll make up for that. These are a few of the international journals that we published. That aside, any AI project that we want to implement has to start with business first mindset because you're trying to solve a business problem. It's not a technology problem that we're trying to solve. Technology is a medium to solve the business problem. So this is a kind of methodology that I would recommend everyone to implement, right? First, you need to understand the problem. Then you go collect the right kind of data, store it in the right place. Then you proceed further with your model building and deploying and helping the people use these solutions. Having said that, I would like to talk about a few key projects that we have accomplished while over a period of, I should say 10 years, so we accomplished close to 260 plus projects. We are a services-based company predominantly. However, I would like to touch upon only a few which really make sense and aligns with the theme of this particular webinar. So wherever we go, for whomever we do the AI consulting work, we try to understand the entire value chain. And then we look at where do we implement AI? And as part of that, we understand that it starts with the raw materials that are procured, right? You kind of procure the raw material from different places across the globe. And in most cases, the prices of raw material will determine how profitable you are going to become as an organization, right? So I'll give you one such example. So here, what we have done is, there is a client which is, of course, into infrastructure building, etc. And they procure steel, iron ore, dolomite, so on and so forth, from different parts of the world. And we told them that if we can forecast the coal prices, iron ore prices, dolomite prices, and your raw material prices at a lower price, if you can forecast that the prices would fluctuate and then there'll be a point where the prices will be the least, then they'll go and procure one. But do you just take the historical data, historical prices, and then go ahead and forecast? Not really. We need to look at a lot of other macroeconomic indicators. And here, what we have done is we have written agents. Agentic AI is making big rounds, right? So we have written agents. These agents will go to open source government websites of UK, of South Africa and Indonesia, etc. And then it will get the details of the bills which are pending in the parliament pertaining to labor. And then it will do the analysis and figure out and give you a report saying that if a specific labor law is passed, then for every extra hour that a worker has to spend, you have to pay 3 times your hourly wage. What does that mean? The coal mining costs will increase and eventually the price. So that will have an impact on the overall price. So this is how we looked at extra macroeconomic indicators also in order to forecast the prices. Okay. We are also very good at computer vision. And here are a few projects. In infrastructure, people will sit down, they will sketch, they will come up with the schedule, bar bending schedule, etc. And someone would manually zoom in, zoom out, and then try to populate all the details in an Excel sheet. If it is a complex drawing, it will take close to 8 hours to 16 hours to just translate this drawing into an Excel sheet. So what can be done is you can build AI solutions around it using computer vision, which will take these drawings and within 8 seconds, under 8 seconds, it will create an Excel sheet like this, which will contain the shape of the rod, the diameter of the rods, so on and so forth. Okay. Yet another example is, of course, the steel, which is used in the infrastructure projects, right? And there are a lot of companies who have a lot of requirements to understand what is the weight of those steel rods when this kind of a lot is placed in their at their workplace. Now, how would you count it? 1, 2, 3, 4? Or you will weigh a bunch, and then how would you conclude what is the overall weight, right? So what we have done is we have come up with an AI solution where you just zoom it and you figure out one of the steel rods, and then you mark that particular steel rod from one point to another. When you do that, it will help you understand what is the diameter of that particular steel rod, any steel rod, okay? And then our solution after that will ask you for certain details such as what is the diameter of that? What is the length of that? And what is the density of this, right? These 2 inputs you need to key in. And this is sufficient for our algorithm, which we built to give you the overall weight. Okay, so we'll just click on OK. And I thought I'll just bring in these real world projects that we have accomplished onto the discussion platform rather than talking about some theory, which is anyways available on internet. And yeah, so it will do masking like this. And then with 92% accuracy today, we are able to conclude on what is the weight of this heap of steel rods which exist. So that makes the life easy for any steel manufacturing company for that case, right? And then Thanks to Akhilesh ji, I got an opportunity to work on a few AI projects as part of ITS India Forum. And here, we do a lot of things. We look at the curves. In fact, our friend Subara was talking about Singapore Land Transportation Authority, and we have done a few projects for them as well, wherein this is Singapore video and the work that we did is in that space, where using the dash cam data, we will be able to figure out whether the curves are damaged or not, whether the curves are faded, damaged, or are they in good condition, how many kilometers of the curb length is good, how many kilometers is bad, damaged, so on and so forth, right? Including the GPS location, so that they understand where they have to spend time and effort to fix the issues, right? This is yet another case study which we have accomplished. The next project is about the cracks. This is one big problem which entire country is facing. So we look at alligator cracks, edge cracks, headline cracks, longitudinal, transverse cracks, etc. And from the live camera feed as well, or from the images that people take, or from the dash cam video, you can just upload the video of, I mean, these are all the real world videos that we captured in order to build a solution. And when you say start processing, it will process and it will determine all the kinds of cracks. And in which location do we have that, whether the crack is small, medium, or large, right? And also, we have, alongside this, created a small dashboard for the different stakeholders, right? Let me go there. Yep. You can select the role, you can select the user, and then you can determine when did you detect that particular pothole, and for how long has it been kept open? Are people really closing it or not? And bunch of other things, right? So we do all this analysis. And these solutions are live, by the way. This is the live, small snippet that I've taken to show you guys. And the next thing is, I believe, even more interesting, where potholes, that's one big problem. This is a video that we have captured in India itself, where our solution will detect using the dashcam video footage. It will capture the area, and our depth library from Python will determine the depth. If you know the area and depth, you will be able to determine the volume. And why is volume needed? Because you'll be able to then classify whether the pothole is small or medium or big, A. And why is geolocation needed? Because if you're going to report it to the government bodies, they should know where such potholes exist. That's it. Is this what you have done? Not really. We have looked at prescriptive analytics also, where we look at what is the raw material which is soft on planet, because everyone is talking about environmental social governance. We have to ensure that there is no excessive harm caused to the planet Earth. So we look at the reusable material, and we look at how much time would it take approximately to fill a pothole. What will be the durability before you do maintenance? How many humans would be needed, right? So on and so forth. And we also came up with an approximate cost estimate, so that when someone is going to bid for this particular road fixing, right, pothole fixing, then how much should they bill approximately? Is it in line with the industry standards or not? And how much of the traffic would be disrupted? So on. These are the kind of projects that we have been doing in the space of AI when it comes to infrastructure, right? There are a few other successfully accomplished projects as well. I would love to touch upon those quickly. For example, say cement manufacturing. Cement is one key ingredient, right, in any infrastructure building exercise. So we work with a few of the leading cement manufacturing companies where they take, they take every 1 hour some quantity of cement which is manufactured, they send it to lab and they determine what is the quality of that in microns. And if they figure out that quality is bad, then entire last 1 hour of the produce, they discharge it. They throw it away. So time is wasted, raw material is wasted, whatever, material you have manufactured is wasted. So what we have done is we have come up with IoT sensors based solution plus AI, of course. So we collected the data of all the IoT sensors of the raw material quantity, the speed at which you are using your clinker, so on and so forth. And then we upfront determine within 10 minutes whether the quality of the cement is going to fall within the control limits or not. If it's going to fall outside the control limits, within 10 minutes, you can take an action. You need not wait for 1 hour. Okay. And yeah, there's one thing in Delhi urban local body, biodegradable, non-biodegradable waste, and how much amount of non-biodegradable waste can be used in the infrastructure. So that kind of work we are doing with Delhi urban local bodies as well. Yeah. So perfect. So these are a few things that I wanted to, showcase as part of today's session. And yeah, I believe I have made up for the last time. Thank you so much once again, Dr. Parida and Dr. Sikdar for providing this opportunity, and hope I added some value. Thank you.
Thank you, Mr. Bharani. It's quite interesting, especially the pothole things, because in CRI, we work with respect to development of new materials by which the potholes can be repaired quickly. But invariably, the decision makers would like to know the number of potholes, the extent, the dimensions of the potholes. So any mechanism by which they can be estimated, like before monsoons, how much money is to be spent or allocated for pothole repair. So that way, means it's definitely possible to do a good planning with respect to addressing the challenges of potholes, which many city authorities are currently they are seized with. We have seen like Bangalore is one. Then recently we had a discussion with Chennai, at Guwahati, and Delhi government itself. So it has a great application. Only thing is that the AI-based application plus the material options, so together definitely can give a very strong and very say effective solutions to people, those who are looking for some practical intervention. I'll just say rest with that. I understand that it's only a primer. It gives a very overview of the idea. And in fact, in the previous presentation also, I said, Professor Sikdar, that we need to go for a much more detailed, like kind of a workshop where we can share these details slightly in an elaborate way so that people can utilize it there in their practice. So, Professor Sikdar, if you allow me, can I now open for the attendees?
Yes, please.
If they have any questions?
Yes, please.
Yeah. So,
invite them to put the kind of questions in the chat or to raise hand, whatever is convenient to you.
Yeah. So I request all attendees, they can raise their hand if there is any questions from the attendees. So one hand raise is there. So Mr. SP Sarma, please go ahead.
Unmute yourself and then go ahead.
Mr. SP Sarma.
No.
So any issue?
Well, are the participants allowed? IRF, are the participants allowed to unmute? or you have fixed it as mute. IRF, anybody in IRF? Can you suggest how to unmute? Nishant.
So there is some issue, I think.
Yeah, there is some issue. Anyway, I mean, I have a comment, not really a question. Like today in the newspaper, it was indicated that Delhi Gurgaon, this 28 kilometer, which is in kind of chaos always. Now they want to improve. And I looked into the news and saw that they are going to overlay it because of the potholes and depressions and cracks and whatnot. And this probably is use this AI-based technique to identify how to economize on it the best possible way. It seems some 2,000 or 3,000 odd crores of rupees are allocated for this work. It could be much cheaper, probably. That's what I thought after hearing Mr. Varane.
Yeah. Absolutely, Professor Sigdar.
Any observation on that? Till after that, we will hear Mr. Sharma.
Your voice was slightly feeble, Professor Sigdar. Only the last part I could hear.
And I was saying that the Delhi Gurgaon, they are initiating a rehabilitation project due to the cracks, depressions, and whatever defects they have. And this is what exactly you have shown how efficiently it can be done and more accurately. And they have in lump sum allocated some 3,000 crores, which probably half of it will be enough to do the job. I don't know. I'm not very clear on that, but at least much economy can be drawn probably by doing things more systematically and technology assisted.
Absolutely, Professor Sigdar. As of now, they have certain mechanism, they have certain machines, but those machines are extremely costly. Okay? If you want to go across a kilometer and then figure out what are the, say, safety equipment which are missing, where are the signages missing, where do we have potholes, so on and so forth, then it's a very costly affair because they are using a lot of LiDAR kind of sensors, which are not cost efficient if you want to scale it across the country, right?
Yeah.
And we need to resort to mechanisms where just a simple dash cam, wherein it can be crowdsourced, we can, enable the even commuters with free dash cam, wherein we get the access onto the cloud, and using those, videos, we can analyze across the country, and then we'll be in a position to figure out how many potholes are there, what is the longevity of the raw material. We can evaluate the performance of the different vendors who have laid the road, safety, devices, so on and so forth. So it'll be an amazing thing to actually explore. And this is exactly what we have been doing with Singapore LTA also. Though they are at a very advanced stage, still they are very keen to, do data-driven analytics as opposed to bringing big machines, sending it across the road to figure out the quality of the road, the cracks and all that. They are resorting to advanced techniques so that they reduce the cost significantly. Yeah.
Yeah, what you said, crowdsourcing, I mean, Delhi Gurgaon, this stretch of 20 odd kilometers, there are hundreds who travel every day. Just put a dash camera and everything can be obtained through that. I mean, what you say is perfectly true. I mean, there are hundreds actually traveling through this, not necessarily in the same lane, different lane, so you can get everything over the days, over a few days. So
Absolutely.
I mean, we can continue with other questions. And Professor Parida, there are a few chat and Q&A questions given. So can you?
Yeah. So one is Mr. Obilesu. He wants to ask a question. Okay. How to we make potholes in national highways identified? Maybe the question is that how to identify the potholes on intercity highways.
Yeah. So this is the same solution, Mr. Obilisu, that we have done, right? So I'll tell you how we can do it. It need not be the vendor who is assigned a stretch, right? Usually on a highway, you take a stretch, and then the person who has taken the contract, he's the person who's responsible to identify the potholes and fix the potholes because they collect the toll and things of that kind, right? Now, should only they be identifying this? Not really. Right? You can have simple dash cam, okay, on the government vehicles also, on the buses, etc. And then that also can help you identify the road. Okay, A. B. As opposed to transporting all that data, all that video to your server to process and figure out where you have potholes, we had something called as edge-based devices, edge-based AI solution deployments, right? Where the video is automatically processed on the camera itself. And to reduce the load, only the inferences or wherever you have potholes, the details which are identified can be written back to the database. And from there, you can communicate it to the respective stakeholders. You can say, when I have identified that. And next time, if the pothole is identified in the same region using geofencing, your geolocation, you'll anyways be able to figure out that. Then that can also help devise an escalation matrix for the government officials where it was identified 1 week back. After 1 week also, it's still the same. After 1 month also, it's still the same. We took 1 month time to fill the pothole, whatever, right? A lot of strategies can be devised around. So hope I answered your question. Traditionally, they use a lot of machines and LiDAR sensors, etc., but that is not cost efficient and not scalable.
Yeah, I think Mr. Barani, every like city authority, they try to know that, but probably they don't have the clues. Like even if the city is divided into different zones, they really do not know what is the extent of potholes, number of potholes in different parts. If they have some limitation of the budget, how they can do the priority, how to do optimized. In fact, in today's webinar, one of the basic idea was that how to optimize the investment which is to go into the infrastructure. So this is a very very clear cut application. Only thing is that it needs to be put into practice by the city governance agencies. For sure, I really liked the presentation. Very brief one. Definitely, we can have a more detailed presentation at some point of time. So thank you very much for sparing your time and be with us. Sir,
Thank
Professor
you.
Sikher, if you would like to say anything.
Is there any other question in the
Sir,
chat?
there are no question, I think.
I see there are three questions in the chat. No, there are no questions. SP Sharma, Obalesu, and these
No,
are
no,
the,
sir. Yeah.
there is no other questions. Sorry, somebody speaking?
No, sir. No, I think we.
Well, I mean, we have reached our time. Actually, we have a little bit of time, about 5-10 minutes. So if there is any further question or any idea or point to be elaborated, Mr. Subbarao is not here, but Mr. Varani, if you want to add anything, please do, and then we conclude. Mr. Varani, do you have any other point to mention? You are muted actually.
No, nothing much, Doctor.
All right.
I'm good. Thank
Okay. In that case, Professor Parida, you can wind up.
Yeah. So we had two interesting presentations today. So Mr. Venkat Swarao, because of some other meeting, he had to leave, but he dwelt on the basic idea of digital twins in a very simplified way. He talked about the details, the anatomy of digital twins, and how to, with the case studies, he could explain how digital twins can be very useful for with respect to the road infrastructure. So he presented the various case studies. One of the case study was with respect to road safety, especially. So we understand that the kind of data, the kind of sensors which has been deployed for some of the smart cities. With these ideas, small pilots can be developed. And in the second presentation, Mr. Varani basically talked about the applications of artificial intelligence with different kind of applications which they have developed. And there was a discussion with respect to the potholes specifically. By a video camera, it's possible to identify the number of potholes, in fact, the dimensions of the potholes. On the basis of that, optimized investment decisions can be undertaken. So these two ideas are both the uses of artificial intelligence and the digital twins. Like they have been very well explained by our two speakers, but I'm sure that we need much more detailed presentations so that people, those who want to put it to use, they can present their case studies in a slightly elaborate manner, which will help others to build these cases. Because like the digital twins is one where you see there are different modules he has explained. Maybe in Peaceville, people have worked in module 1 or module 2, so they have expertise in that. But then it is like more like developing an integrated approach, so that we can definitely understand with a much detailed presentation. But it's definitely high time to build these kind of case studies, or to put these means new tools, new applications for actual real life highway infrastructure projects. So with that, I thank both the speakers. I thank Professor Sikdar for introducing me and initiating the session while I had difficulty in joining in. And I thank all the attendees, those who are attending this webinar online. So I would also thank the IRF logistics team, the IT team, which has been very vital for organizing, for fixing up everything, and conducting this webinar so smoothly. So thank you, everyone.
Thank you. Thank you. We close the webinar now. Thank you very much.
Okay, thank you.
Thank you all. Thank you all.